Hello everyone, welcome to CSC Core Concepts in the series of Compiler Design. I am Dr. Sonali and I welcome you all. In this video, we are going to solve some more problems of DFA. In my earlier video, we have also discussed some of the problems, so you can practice more and more examples of DFA. So let us get started with it. So let us construct a DFA that accepts all strings over AB starting with AB. Now the string should start with AB means what? After this group A and B, you can have any number of A's and any number of B's, right? So how will the language set look like? You have AB, then you can have any number of A's and any number of B's, okay? So how will your DFA look like? So you give a start with the minimum string possible, that is AB, you reach the final state. Now, after this AB, you can have any number of A's and B's. So self loop is okay. But what if you get a B over here? Then it is an invalid input. So in this case, we go to a state which we called as a dead state, or we also called as a trap. That means what? This is not going to lead you to any valid state. Now, even if you have a string like say B, A, B, something, it is not at all valid. So if your first alphabet is B and thereafter whatever it is, it does not make any sense. You will remain in the trap state only. So if you put anything A and B after this, you will remain in the trap state. Similarly, here between A and B, nothing should come. So if you are putting a in between A and B, then you will lead to a trap state. Okay, and it is starting with AB. So you cannot have a string AAB. If it is not starting with AB, then this would have led to the previous state. But here it is not so. So this is what is the beauty of DFA, that you have to show any deterministic state, right? Even if it is a trap state or a dead state, you have to depict it. Next, construct a DFA that accepts strings containing AB as a substring. Now, when you have AB as a substring means what? Before this AB, you can have any number of A's and B's, and after this AB also you can have any number of A's and B's. So you have A, B, and you go to the reach the goal state. So this is your language, right? So now you can, after AB, you can have any number of A's and B's, and you can have any number of B's before A. You can have any number of A's before A. Now let us go to the third example, that DFA that accepts all strings over AB containing ABB as a string, right? So ABB should be a substring. So before ABB you can have any number of A's and B's, and after ABB you can have any number of A's and B's. So the string can be, the minimum is ABB. Thereafter you have AABB, you can have any number of B's and so on. So let us first make the minimum string possible, that is A, B, B, and you reach the final state. After ABB, you can have any number of A's and B's, and before ABB also you can have any number of B's, right? But in between, if you have AABB is also allowed, AABB, then you will not reach this state. But between these two B's, no A's is allowed. So what if your input is A here? Then you have to go to the previous state, Q1. Until you encounter a B, you cannot go to the Q2 state. So if you get a here, you go over here. So if my string is A, let's say. So with the first A, you come to the Q1 state. With the second A, you remain in the Q1 state. With the third A, you remain in the Q1 state, right? And then you go to a B. Now suppose your string is AB. Okay, this. Then again you have, this is an invalid string, right? So you have to go back here. If you get an input, you have to go back to this previous state. Then construct a DFA that accepts all strings which ends with AB. Now this is very interesting. If it ends with AB means what? Before AB, you can have any number of A's and B's. So AB is fine, you have a final state, right? Now, before that, now here I will show you something very interesting. Generally, students have a habit of showing a self loop without thinking. Now, if you keep a self loop over here, what does it mean is that after this AB, you can have any number of A's and B's, which is a wrong concept here because your string should end with AB, means nothing should be here. So, if you get a AB over here, then what we will do, we will come to it. But yes, let's see. If I get a B here, I can have any number of A's and B's before AB. I will remain in this state. I can have any number of A's, it's okay. But if I get a at the end, I should go to the previous state. If I get a B here, I should go to the Q0 state. Okay. Then only it is a valid. You cannot have a self loop blindly written at the end. So if you get now, if you let's say this is a string AB, right? It should end with AB. Now suppose if here before AB. After AB, you are getting A. Then you will remain here. So your string can be AAB. It is okay, right? If you are getting B here, right? After AB. So BAB is also okay. Understood? BAB you will go over here. Understood? So this is okay. But if you have written a self loop here simply without thinking, that is not valid. Self loop means what? You remain in that final state. But your final state here is acceptable only when it is ending with A and B. So I hope you understood this and you can have more and more examples solved like this. And in my upcoming video, of course, we will solve some more DFA examples and thereafter we will start with a non-deterministic finite automata, that is NFA. So stay tuned to this channel and don't forget to share and subscribe to CSE Core Concepts. Thank you.